Cool, the recording has started. So I just thought I'll make a quick tutorial using this Casio over here, which I'm not sure what the specs exactly is, but it's this one over here. There is a newer model. I'm sorry, it's the same model but a different look. It's the white one. If you are aware, maybe I should show you that model quickly so that we're all on the same page prior to progressing with this mini calculator tutorial Casio. Just so calculator, and the one I'm referring to is this one. That's the one. So this one has, well, not exactly, but it's this one. It looks like this. I just can't find the exact one with the brand. Let me have a look. It's the FX something something. So let me just quickly have a look. I don't see it here. Just do a check here. FX. Okay, it's not the black one, but it's the other one. Okay, so this one doesn't have the functionalities which I'm talking about. So you obviously want to have the one that I'm using. Okay, anyway, let's begin. It's the 911ES Plus. That's the one, but it just looks a bit different. I'm sure you've seen it. Yeah, it looks like that. That's the one. Okay, yeah, that's the one as well. The 911ZA Plus. This is the one. So you can either, that's the new one, and then obviously the older one looks like that. All right, so let's quickly see. So what I'm going to do is just give you, how do I say, a method of verifying your answer, right? A method of verification, essentially. So this is the question, right? We want to solve Cramer's rule for X and Y, right? Two equations, two unknowns, and obviously they want to use Cramer's rule. So obviously you're going to do that. But then what you can actually do is verify your answers as you move along. Okay, so that's the question we're going to do. So what I'm going to show you first is how to actually get the X and Y values to meet this equation, assuming that you understand that when you find your X and Y values and you put it back into these equations, it should give you this answer. Okay, so let me show you to do a 2x2 or two equations to unknown. So you got your Casio over here. You want to make sure you over here, you want to go to mode, you want to go to equation, and you want to go to the first one. Right? That's very important. What's important here to note, when you do this, look at the standard, you'll click number one, but look at the standard form. It'll be X and some coefficient, Y and some coefficient equal to some constant. So it should be exactly the same over here. So you want to have your constant on the other side where it's equal to 0. So it must look exactly the same. Nevertheless, you click 1, and all you're basically doing is putting in the coefficient. So 3 would be the first one, 4 would be the second one, and 13. These values are coming from there, there, and there. You do exactly the same over there. 2, of course, there's a -5, we should be cautious of. Then you click 1. And when we click equal, automatically the calculator will solve X, which is 3, and Y, which is 1. So if you have a look over here, your answers are 3 and 1. Okay, so that's perfect. So that's a way of verifying a 2x2. To check if my answers are correct, what I can also do is, like I said to you, I'll just go down here. 3, right? So I'm using the first equation. 3 times X was 3, I believe, plus 4 times 1. And of course, this should give me an answer of 13. And if I get 13, that's probably right. I can verify with the second equation as well. 2, 3, minus 5, 1, that'll be my y value, and I should get the answer of 1. So if those two values get in here, you're basically verifying those equations, therefore it's correct. Okay, so that's a shorthand of doing a two equation to one node. But let's say you wanna find the determinant, right, to verify your determinants as well. Assuming you know how to choose the correct determinants, that's very important. Yeah, I'm assuming that knowledge is in place. You want to go to mode, go to matrix 1, and you're going to choose number 5, which is a 2 by 2, right? 2 rows, 2 columns, okay? All you then simply do is put in your selected elements, 3, the 4, the 2, the -5, right? Once that is done, you just go on. So it's stored in that matrix A. You want to go shift matrix, you're going to go to number 3, which where matrix A was stored. You're going to go shift matrix and you're going to choose number 7, which is the determinant, right? So 7. But then now we need to find the determinant of matrix A. Then it's shift matrix, we choose number 3, we close the bracket, and we press equal. And the answer will be 23. Perfect. You can do exactly the same with your delta X. I'll do that one as well. So this one, I'll declare matrix B, right? So you go 6, number 2, it's a 2 by 2, 2 rows, 2 columns. So 5, then you go 13, you go 4, you go 1, -5. That, remember we store that in matrix B, we go shift matrix, we go to determinant again, shift matrix number 4, which is where that was stored, and press enter. And you notice you get exactly the same determinant. So obviously what's important is that you need to know how to do it analytically or manually. And obviously all you can use a calculator is to basically to verify your answers are correct. Okay, so we've done the 2 by 2. And now I want to take it a step further where we look at 3 equations, 3 unknowns, which is essentially this over here. Okay. 3 by 3, I just mean 3 equations, 3 unknowns. Okay. So this one, follow exactly a similar procedure. Make sure, of course, you want to put this in X, Y, and Z, X, Y, and Z, X, Y, and Z, or X, Y, and Z. Make it equal, make the constants equal to the other side, which will essentially look like that over there. So let me just zoom this up for you. Zoom. Okay, let me just zoom. So what I'm going to show you now is how to get the exact X and Y values, right? So you will get the answers and you kind of working towards those answers. So you go to again mode, go to 1. You go to mode again, you go to number 5, which is equation. And then you choose number 2. You'll notice at number 2, there's an X, there's a Y, there's a Z, and it's equal to some kind of constant. It's exactly the same as this. Click number 2. What we then do is populate the constant. So this will be the first line, which is 1. It's coming from over there. -3 coming from there. We've got 4. And don't forget the D on the other side, which is 5. Perfect. We then have 2 over here. We have 1. We have 1 over here. And we have 3. We have 4. And we have 3. We have 5. And we have 1. So once you've populated the matrix with the coefficients, all you do is click equal. And you show the X value as, let's quickly have a look. That's 3. That's correct. Tick. -2, correct. And -1, correct. So there we know exactly what the answers we should work. And of course, as per the similar procedure before, if you decide to check if the values are correct, obviously you want to put the X and Y, Z values here, and it should give you the answer. So 1 times, what was the answers again? It's 3, right? So that's 3. Okay, you go back. Minus, oops. Okay, minus, I believe the second one is -2. Okay, plus 4. And the answer for Z was -1. Okay, so that's bracket -1. And we're expecting to get equal, we're getting 5. If it's equal to 5, that means satisfy the condition of the equation, so it's correct. We can verify again with the second equation or even the third equation. Let me do the third equation. So it's 4. My x value was 3, I think. Plus 3 was at -2. Then plus 5. Oh, okay, let me do this again. So 4, 3, plus 3, y was -2, plus 5 was 1. Just verify that. So I'm just putting all that x and y, z values back into here. Let me have a look. If you have a look, 3, -2, -1. So it's -1. Okay. And if I press equal, you'll notice that it's a 1. Right? So we know that those values are correct. You can do exactly the same thing to check over here. Same thing. Again, what I'm showing you is just a method to validate your work. So now you might be asking, how do we find a 3 by 3 determinant, right? Cool. So again, I'm assuming you know how to set up the determinant by eliminating the rows. I mean, you know, the constant terms in this case. Not sure if you guys are aware of that. I'm assuming you've covered that. What you then do now, I'll show you how to get the determinant. Okay, so we're just going to do this one. You go to mode, you go to matrix again, and this matrix 1. In this case, you're going to go 3 by 3, right? So why 3 rows, 3 columns? Okay, you just click on number 1, and we just populate the matrix as you. So it's 1, -3. It's these values, 1, -3, and then 4. Subsequently to 1, 1, 4, 3, 5, right? Cool. Once that is done, you just go on to store that to matrix A. We go shift matrix number 7, shift matrix, and then you want to choose number 3. So remember, we stored that in number 3. Is equal, and we should get our determinant of 28. So as you solve, what you can actually do, you can actually verify each step, so you know. So for instance, if you had to get 24 or 20 or 19, you know that you're wrong over here, and you have to actually go back over here and go verify your answer. So you can do exactly the same over here. Or in or off. Let me do this one. So you go mode 6. You can just store that in matrix B. We know it's a 3 by 3. 1, 1, -3, 5, 2, 1, 3, 4, 3, 1. Press on. That means we've stored it. We go shift matrix number 7 to find the determinant, shift matrix and matrix B. Right? Once you've solved, you check, verify, and I got -108. So let me just go verify on matrix B. So I go to shift matrix and I press number 4 and say equal. I just check what I've typed in. Oh, I've typed in 11 instead of 1. So let me just redo my matrix B. So shift matrix 4 equal. I can't change it here. So let me go back here, mode, shift, mode, mode 6, matrix B, 3 by 3. And then I'll store it, just put a 1 in there. Okay, so 1, -35, 2, 1, 3, 4, 3, 1. It's always worthwhile checking as well. Once that is done, repeat the same procedure. Matrix 7, shift 4, and then 4 stored over there. And I believe we should get the right answer of -28. So as you solve, you can actually use that to verify each individual step. Cool. Yeah, let me know. Plan to post another video using complex numbers, where you actually can use complex numbers on this calculator. Cheers.